In this lecture, we are going to take a look at another new problem, which is basically also an extension of the previous problem we look into. And this new problem is entitled Computer Assisted Instruction Monitoring Student Performance. And it reads, more sophisticated computer assisted instruction systems monitor the student performance over a period of time. The decision to begin a new topic is obtained based on the student's success with previous topics. Modify computer assisted instructions to reducing student fatigue program, that is the previous program we created, to count the number of correct and incorrect responses typed by the student. After student types 10 answers, your program should calculate the percentage that are correct. If the percentage is lower than 75% display, please ask your teacher for extra help. Then reset the program so another student can try it. If the percentage is 75% or higher display, congratulations, you are ready to go to the next level. Then reset the program so another student can try it also. So based on whether the student get the 10 answers correct or he doesn't get the 10 answers right, still the program will exit after asking 10 questions consecutively. All right, so this is since this is a modification of the previous program, what I'm going to do, I will just go over to the previous program so that we don't need to start coding from scratch. I will just copy everything. I'll just copy everything, and then I'm going to paste it and then make the necessary modifications. So I'm going to paste it here. So I'm going to close Kai2.c. all right, so over to Kai3, and then let's see the necessary modification that we are going to make. So let me just enclose this particular function. Likewise this one, let me enclose it. So modifications is basically in this particular function multiplication. Remember that this in this multiplication, the way we coded it is that it's going to continuously repeatedly keep asking questions. It will repeatedly keep asking questions until the user you enter -1 to exit the program. But in this case, we just want to ask 10 questions. All right, so that means that our modification is going to be here. So so we don't need this. We don't need this. Print enter -1 at any time to exit the program. We don't need this. So I'm going to remove this. I'm going to remove this into response. And also, since we know that we are going to ask these questions for 10 times, this is where the for loop comes in handy, where we can make use of a counter to count up to 10 times. So I'm going to just write for int I, my counter I, because it says 1, from 1 to 10, I is less than or equals to 10, and then we increment I, and then we increment I after each iteration. So, and then let me end 4 here, and 4, right? So for each iteration, I want to ask a question. I want to ask the user a question. All right, do I need this? No. So I'm going to ask a question. So let me do away with this. But I need this int number 1 to generate the numbers for me, and then ask the question, and then let me copy this up to this one here, and while let me copy this one here. Okay, let me go down. Okay, let me copy from here, and just copy these ones here, this line, this code. Let me copy it, and then let me come and paste it here. Alright, so what the program is going to do is going to ask for the first iteration. It's going to generate either run function, generate a single digit number 1, generate a single digit number 2, and then ask the multiplication question and get the response from the user. Now check the response, but here we are not checking for whether the user enter my -1, so I'm going to remove this. So check whether if the user enter the correct response, and if the user enter the right response, then negative feedback. Then it's going to enter the is going to print out the negative feedback, and then get the next response. So get the next response until the user answer the question correctly, and then if the user answer the question correctly, which is a line number 55, print out positive feedback, and then we hit N4. All right, so that is I think the way we are going to implement this. And then so since I have make use of this, let me just copy it, do away with it. So I'll just do away with this. I'll put this end while here. All right, so now let's see more modification that we need to do to the program. And then we have this print program will now exit. All right, so let's go off again and then see what we are supposed to do. What the program says, it says after the student type 10 answers, your program should calculate the percentage that are correct. If the percentage is lower than 75 display, please ask your teacher for extra help. Let us set the program so that I can if the percentage is 75 or higher. Okay, so after the student type 10 answers, the program should calculate the percentage that are correct. So now that means we need a counter to keep track of the responses that the user enter. So what I'm going to do now, okay, while the response is not negative feedback, get the response. Okay, no, response no customer. We don't need this. We don't need this. It's positive feedback while the response is not equals to number times number, negative feedback. Then okay, so let me do away with this also. N4. All right, so I say we need a counter to keep track of the so we have int, let's say positive counter, positive counter, and then let's have another counter, int negative counter, negative counter. All right, negative counter. So now let's go down and then let's have so negative feedback. That means that here at this point the user has a negative response, so let's increment the negative counter here. So what I'm going to do before outputting negative response, let's increment our negative counter, plus negative counter, and then also likewise here. So it will only enter the while loop in here. That is if the user did not enter the right response. Now, but if the user has the right response, then it will just print out a positive feedback, and then we also want it to increment the positive counter. So let me increment the positive counter. So increment the positive counter, and then now we have additional something that the program requires us to do before the program exit. Now after looping 10 times for 10 questions, after asking 10 questions, now we want to check if the user enter in as the program says. Let me go back to the question. It says after the student type 10 answers, your program should calculate the percentage that are correct. If the percentage is lower than 75, then display please ask your teacher for extra help. Then reset the program so another student can try it. If the percentage is 75% or higher, then display that are correct. So let me go down here and have something that we check. Now we are going to have positive counter, positive counter, then divide by a summation of positive counter and negative counter. Now after dividing this, and then we want to check if it is less than 0.75 as the program says, and in that case, if it is less than 0.75, then so in essence what I'm saying, we want to find the average, that is if the number of positive response is greater than 75%, is greater than 75%, then we should print a positive additional positive response that are correct. If the percentage is lower, then display is 75 or higher, then display congratulations, you are ready to go to the next level. So we need to display print out this additional something here. So let me copy it. So and then we need to print this particular statement here. So print no is a less than if positive counter that is greater than 0.75 is greater than 0.75, so we should have a positive message. Congratulations, you are going ready to go to the next level. Now then we have the else part here. Else we also print out something, print format negative s, but in this case we are going to print a negative response. So that means that the percentage is less than 0.75, so we want to print out a negative response, and the negative response we want to print is please ask your teacher for extra help, which is asking them if the user did not perform up to expectation. So we need to print out an appropriate message. So just print out this here, please ask your teacher for extra help, please ask your teacher for extra help, else. All right, so this is where we are, this is what we have. This is what we have. So also over here we are going to encounter an issue here, because what this is an negative division. If we divide integer by integer, then we are going to end up with a negative division. And what will happen in a negative, I'm not sorry, not negative division, integer division rather, integer division, where we are going to have an integer division. And what will happen in integer division is that any remainder is going to be truncated, only the whole number. So when we divide, say 5 by 3, when we divide 5 by 3, we know we have 1 and some reminders. Now we're only going to have 1, so we are not going to get the exact result. So I'm going to perform what we call casting. So I'm going to cast the first, temporarily convert this one of these temporarily convert the divisor positive counter, which is the divisor, temporarily convert it to a floating point number. This is called casting. So at this line number 63, this positive counter, which initially was an integer value, is going to be converted into a floating point number, and then now is going to be divided against a negative, an expression that we will yield a negative, an expression that we will yield an integer value, because positive counter is integer, negative counter is an integer. When we sum them off, we are going to have an integer value as well. But since we are dividing a positive value, which is the dividend, rather positive counter is the dividend, while this the one in the denominator is the divisor. Now is going to also convert the one that has a narrow range to the data type that has a wider range. So in this case, in essence what I'm saying, we know that the denominator here, which is the divisor, positive counter, which is the mixing things up. Positive counter is the numerator, which is the divisor, and then we have the denominator is the dividend, the number that's going to be divided against. Now, what we are the denominator is an integer, so and we are dividing a floating point number against an integer, so the denominator also is going to be converted to a floating point number instead of leaving it as integer. So we are going to divide so that both the divisor and the dividend are going to be of the same data type. And if it happens that one of the data type has a wider range, then both the dividend and the divisor are going to be converted to the data type that has the wider range. So in this case, both the numerator and the denominator are going to temporarily be converted into floating point number, and then the division is going to be carried out. So that instead of us having an integer division, we are going to have a floating point division, where we are going to have an exact result that consists of both the number and the remainder, both a whole number and the remainder, both the quotient and the remainder. All right, so that is in essence what I'm trying to explain here. So now let's save this program, and then now let's go and here, let me just go by it briefly if there's any integer. So we have this, we have response, but we have not declared response as a variable type. So let me have here, I'm going to declare it here. It's going to ask, we have not declared response. And we have int response, your response. All right, so let me go and compile this program, and then if there's any error, I'll come back and fix the error. All right, so let me come to this particular terminal here and clear the terminal. So we have GCC, we have Kai3. Kai3.c. I want to output it as Kai3. So perfect, our program has compiled successfully, but let's hope that we are going to get the right expected output. So Kai3, we run it. How much is 5 times 4? We have 20. Nice work. How much is 6 times 0? 6, 0. Very good. How much is 1 times 7? 7. Nice work. How much is 6 times 4? 24. Very good. How much is 8 times 4? That's 2. Keep up the good work. How much 8 times 2? 16. Keep up the good work. How much is 0 times 8? 0. Excellent. How much 1 times 9? 9. Nice work. How much 9 times 2? 18. How much is 5 times 0? 0. So as we can see, this for the positive response, it is working according to expectation. Keep up the good work. Please ask your teacher for extra help. No. The program, we are not supposed to print the negative message. Please ask your teacher for extra help. So we need to go and make why are we getting the negative response, negative feedback? We said if is greater than, then we should print this particular message is greater than. If positive counter divided by positive counter negative counter is greater than 0.75, then we should print this particular message, and then else we should print ask your teacher for extra help. So why are we having that other something printed out? The program will now exit if we have the if condition, and then we have the else part. It's less than, is greater than 0.75. All right, so let me change it the other way around and see. It's less than 0.75 according to the question. 0.7, and then we should print out the negative response. So let me copy this one, call X. But in other way, it should work no matter whether we were. Wait, let's do it this way and see. Let me Control X, and then print this one like this. So we have this if and if. So why am I having this bracket? Whether it is one that is even causing the issue. And then I have this. And then I should end my else here. And else. Please accept this teacher for extra help. Else. Alright, so let me go over the program again. Please ask a teacher for extra help. In this case, and then after this, we should print a new line. Let's print a new line character. All right, yes. Also after this one, let's have a new line character as well. So let me go back again and then recompile the program and then run it and see. So let me clear this terminal here, and then. How much is 8 times 6? 8 times 6, 8 times 6, 42. Wrong. All right. 8 times 2, 8 times 16, 54. Now please try again. Okay, let me check my calculator. Let me check my calculator. How much is 8 times 6? 8 multiplied by 6. 48. Alright, it's 48. So we have 48. How much is 5 times 8? Is 40. How much is 4 times 4? Is 16. How much is 8 times 9? Is 57. Now please try again. 64 we are to 64 72. Nice work. 5 is 0 times 5 is 0. 2 times 3 is 6. 5 times 2 is 10. 9 times 2 is 18. 0 times 4 is 0. 1 times 4 is 4. Excellent. Please ask your teacher for extra help. The program will now exit. So all right, so let's go over it again and ask your teacher for extra help. So we didn't get our responses. Our correct responses are less than 0.75 number of times that we answer it. Please ask the teacher for extra. Okay, let me please format this. Let's ask your teacher for extra help. And so here. Let's have a new line. Should we have a new line here? Should we have a new line here? New line. New line character. All right. So let's go over the program again. And then run it. How much? 3 times 1, 3. 9 times 2, 18. 6. 8 times 7, 54. 7 times 7, 49. 49. 50, 51, 52, 53, 54, 55, 56. This is 0. 56. 6 times 4, 24. 3 times 0 is 0. 8 times 4, that's 2. 8 times 0 is 0. Nice work. Please ask your teacher for extra help. The program will now exit. So as we can see, this program is working correctly. And if we didn't, if our responses, correct responses are less than less than 75%, as the question says. If they are less than 75%, then we are going to have a negative, rather a warning, something that will encourage us to work harder please ask the teacher for extra help, a remark that will prompt the learner to go and double up his effort and seek for further guidance to help him in tackling this particular computer edit instructions in drilling, because it's a drill the drill and practice. This is a category of computer edit instruction called drill and practice. So to help him, they need to double his efforts to learn more about that particular drill and practice that the computer edit instruction is all about. So basically this is how it works. So try run the program and put all the responses right and see the kind of response you are going to get. So thank you for taking the time to watch this video, and if there is any question, please you can post the question under the comment section. Thank you.